Hi there, this is Xavier, your host. I just wanted to remind you that half of the Chicagoland episodes are bonus episodes that you can access by paying $5 monthly on patreon.com/Chicago_land. One issue though, if you're using an iPhone, make sure you go to the Safari app before paying, because if you try to do it directly through the Patreon app, then Apple, the company, takes some of that money and pockets it for themselves. Anyway, enjoy the episode. Okay, so to get this straight, you were walking down the street perfectly normally at night, and then you were bombarded by hot phosphorus?
I think that's what's in fireworks. So someone was like on the street next to me,
Yeah.
like I think a street over, was lighting them off.
Yeah.
And there was one that was a dud that arced down. And I actually had my phone out and I was like recording the fireworks.
Yeah.
And the one landed like 15 feet from me. And I kind of was just like, did this happen? Is this like, how much of a dud is this?
Yeah. So you had
And
to
then it just went off. It went off.
Oh. Jesus.
I didn't get any closer to it, but I also didn't like run.
Yeah.
Which maybe I should have, but like clearly I'm fine.
Yeah, you made it. You made it. Well, congratulations to the United States for taking over for another year, I guess. Welcome to Chicagoland, the geographic history of Chicago and the American Empire. Yeah, so welcome to my guest, Ali Mezzi, a lawyer from Chicago.
Hello, thank you for having me.
Lovely to have you on. So our topic for today is the Calumet region. For those who don't know, I guess I would say the Calumet Watershed is a land of superlatives. In his book, A Natural History of the Chicago Region, Joel Greenberg wrote that, quote, "The western Calumet area has experienced every abuse that a wealthy society can subject to a small surface of the earth, except significant radiation exposure and warfare."
I believe we can do it.
Yeah, we can get it all the way there. I don't know about World War III, but World War IV will be fought on the Indiana shore.
It's going to be the War of Succession of the Great Lakes Republic.
Yes.
The Great Lakes People's Republic.
The canals of Calumet Harbor near South Chicago were so polluted that for most of the 20th century, sludge worms were the only animals that lived there, and during the 1960s, apparently even they couldn't survive. And yet, simultaneously, the Indiana Dunes National Park is one of the most diverse protected habitats in this country. Only the Great Smoky Mountains and Grand Canyon National Parks have more native plant species, and both of those parks are more than 20 times larger.
Yeah, there are cactuses at the Indiana Dunes.
And there are cactuses at the Indiana Dunes. Yeah, there's like
They're little guys. They're little guys, but they're there.
It's such a crazy diverse habitat because you go from everything from like I don't remember what they're called offhand. This is for a future episode, but this is for the next episode. But boreal manzanita relatives live in the same dunes as prickly pear cactuses. Editing Xavier here. The plant I was thinking of is the kinnick, also called a bearberry.
Right, yeah. And I think like another crazy thing about it is and I'm sure this happens a bunch of places, but it's always a little crazy to see like a forest growing out of sand. Where like, the sand is the soil, at least at the top.
Yeah.
But the forest just coming directly out of.
And in many cases, the roots of the forest are like holding the sand up.
And that's how you get eaten by sand dunes.
And that's how you get eaten by sand dunes, because there's a little cavity under there, as we've learned. Horrifying. So for the next 3 or 4 episodes, I haven't finished writing them yet, we'll be looking at that region of the Chicago area. Oh, I guess I forgot pronouns. Xavier. I'm your host, Xavier, he, him pronouns.
I'm Allie. My pronouns are she, her.
Perfect. So yeah, Allie, I think that in my mind, I think of you as a student of all things fringe and cult. So I think you'll probably appreciate that the Calumet area occupies sort of a weird marginal position in Chicago history.
It definitely does. It is kind of like on the fringes between like just so many different worlds. It's also like a little bit of a liminal space in
Yeah,
that like you pass through it often.
yeah.
And there are people that do live there, but a lot of the times they're old.
Oh, sure.
Not like, but it's you tend not to like know someone that lives there, or you like, you did know your great uncle that lived kind of in the like, in that area, but then he passed away. And maybe, maybe it's just groups of people cycling out and cycling through. Or,
Sure.
you definitely have family that worked in the region over
Yeah.
there.
Yeah. Right, and I should specify that you, Allie, are a Northwest Indiana native in the sense that you were born and grew up there.
That's true. I was born in, well, super technically, I was born in Hammond, grew up in Cherville, and I've been living in Chicago for a while now.
Yeah, totally. And to specify, the Calumet region, as we're defining it for this series of episodes, is the historical watershed of Lake Calumet and the two Calumet rivers along the southern shore of Lake Michigan. So that's most of northwest Indiana and a chunk of sort of the southern Chicago area.
Oh, I was thinking of like a really, really specific part of the Calumet region when I was calling it liminal, because of course a lot of people live in that area.
True, yeah, taking it as a whole. But you're right in that there's a lot of I don't know. I think it's also liminal in the literal sense that it's on the edge of the lake. It's also on the edge of the Chicago urban area. It's on the edge of the swamps, and so there's a lot of things coming together in that way. So yeah, so this story is in part a geographic story. So let's get it started at the geographic beginning. So the bedrock underneath Chicago and northwest Indiana is pretty old, between 350 to 420 million years old. And the rock in northwest Indiana is a little younger than in sort of Chicago proper. So there are very few places around Chicago that we can actually see the bedrock because of the sediments and soils that were laid down by glaciers during the ice ages. The few places where the bedrock sticks up above soil are ancient reefs, made up of type of stone called dolomite. What's your impression of dolomite as a layperson?
As a layperson, I don't think I've ever really considered dolomite. Um, if it's not a thing that I've thought about, if that's a picture of it,
This is actually limestone, technically, which is related to dolomite.
I like the shells.
The shells are nice. So technically, dolomite is made from limestone, and the limestone goes through a chemical change that makes it harder. So that's what dolomite is. It's chemically transformed limestone.
So are all of like the buildings that are made of like say Indiana or like Illinois limestone, are those dolomite or have they not gone through the chemical change?
Yeah, that's a great question. So the most common building material when you hear about Indiana limestone, it's from the sort of Bedford, Indiana region of
Right.
southern Indiana, which is proper limestone.
Okay.
Yeah, so geologists would call it dolomite if it's undergone dolomitization. Although
Very
maybe,
creative.
yes, although
So
maybe,
is it like is the process like a very unique thing to limestone and dolomite, or are other like rocks and aggregates and stuff, do they have similar processes that do kind of the same thing in like by the same mechanism?
I wouldn't say that. No, I would say this is a distinct mechanism for limestone. Yeah, and this isn't like metamorpho. This isn't like metamorphism. This is not like. This is dolomite is still a sedimentary rock. Yeah. So specifically, do you know where limestone comes from? There's a hint on the screen here.
Space.
No, no,
Lyme, Connecticut.
no.
Lyme
That's where
disease.
Lyme disease comes from. It is actually named after Lyme, Connecticut. Anyway, no, it comes from shells. It comes from the discarded skeletons, hard skeletons of marine organisms.
From space.
From space.
Anyways, continue.
Ultimately, everything comes from space. So, just like a sedimentary rock that's made up of sand or mud particles, would be pressed together into hard stone. Limestone is a sedimentary rock made up of fossilized animals. And very often, you can actually see the fossils in limestone. I don't know if you've ever noticed, so this is like all of my friends went to University of Chicago problem again, but this is a University of Chicago connection because many of the old buildings on campus were made out of Indiana limestone. And if you look carefully, you can actually see fossils in them frequently.
I have noticed some fossils in them.
Heck yeah.
Or I've been in like a lot of government buildings that were made
Oh,
of
yeah.
Indiana limestone in like various places. And if you just get like close to like the pillars or something, like every once in a while you'll be like, oh, there's a shell.
Yeah, exactly. So specifically here you can see the context of sort of southern Indiana near sort of around Bedford and Bloomington.
Do you know if Bedford still actively mines limestone?
I think they probably do. I'm not sure. Can look into it. But you can see all of these sort of giant pits in the earth, which are limestone quarries. So I just thought it was cool to see, where the limestone comes from. All right. So if we compared the Indiana limestone from Bedford, though, it's actually younger than the dolomites that we see in the Chicago area.
Mm.
Specifically, the bedrock under Chicago is closer to 420 million years old, and that's from the Silurian period. The reason that that's the case is that Chicago is sort of in between the basins of two. It's sort of in between two ancient bedrock basins, both of which contained large shallow seas until around 300 million years ago. So you can see here to the northeast of Chicago area is the Michigan Basin, and to the southwest is the Illinois Basin. So those would have been actually exposed bedrock at one point in the distant past. And now they're sort of filled in. So over hundreds of millions of years, the sea levels rose and fell, but the basins, the Michigan Basin and Illinois Basin, were underwater pretty much that entire time. So even though the Chicago area, here labeled as the Kankakee Arch, even though the Chicago area rose above sea level sometime around 400 million years ago, the basins on either side were still underwater, which meant they continued to fill with sediment. So that's why they're younger rock. What we're looking at here is a transect of Michigan and the sort of areas on either side. So the little red line that I drew shows where this transect cuts across. And this is the Michigan Basin. So you can see how that would have worked each time there was, a sea over the basin. Or I suppose there was a sea continuously over the basin, so the different types of sediments continued to accumulate in this sort of bowl shape, and you get these sort of multiple layers of bowls.
Because, it kind of in this, it looks like it's a little raised, but that might just be because of the water, right?
That's right. And so the water on either side, which are the Great Lakes of Lake Michigan and Lake Huron, were actually cut into the bedrock primarily by glaciers.
Okay, cool.
Which is why the Michigan Basin is raised, even though it was historically a basin. But you can see that it's got the youngest rocks in the area.
Very cool.
Mm-hmm. So once the Chicago area was on dry land, its sediments started eroding downhill into the basins. But the harder rocks, which in this case were the dolomites, eroded away more slowly over hundreds of millions of years. So to the north in Wisconsin, the Silurian dolomite actually sticks out of the ground as part of the Niagara Escarpment, which here is shown in black, labeled Silurian rocks. So you can see that peninsula that sticks out of Wisconsin, called the Door Peninsula, which encloses Green Bay, is part of the Silurian dolomite, aka the Niagara Escarpment. And you can see it forms a ring almost all the way around to the Niagara Falls, which is why the Niagara Falls are so tall, because they're falling over this big, hard dolomite rock escarpment.
So how did it form a ring? Is it because that's around the outside of the basin?
Yeah, it's part of the basin. Exactly. It's like the rim of the basin.
The lip of the bowl?
Basically, yeah. Yeah, actually, that's literally what I wrote down here. Yeah, so we're good. So the rocks that lie under Chicago are the same ones that the Niagara Falls goes over. And like I said, dolomite is limestone that's been chemically transformed. We're just going to cover the basics of the chemistry here. Limestone is made of calcium carbonate, which is a positively charged calcium ion paired with a negatively charged carbonate ion. And carbonate is CO3. That's 1 carbon and 3 oxygen. It's the same thing that you put in water to make it fizzy. That's carbonation. And if you live somewhere with hard tap water, you're probably dealing with calcium ions leaching out of the limestone into your water source. The reason limestone is made out of calcium carbonate is because seashells are made out of calcium carbonate and lots of other sea life. For example, corals secrete calcium carbonate at the base of the rocks they live on. So they're continuously secreting and building a sort of calcium carbonate base that they live on top of. And over time, the amount that they secrete grows and grows and becomes what we call a reef. During the Silurian period, there were 2 main types of coral. There were rugose corals and tabulate corals that were building reefs. Both are extinct today.
Mm-hmm.
There was also a extinct group of sea sponges called stromatophoids, which also contributed to reef building. So between the crushed seashells and accumulated reefs, we end up with large deposits of calcium carbonate that were pressed together to form limestone. And then the dolomite formed when some of the calcium ions in the limestone got replaced by magnesium ions.
How does that happen?
Yeah, how does the magnesium get in there? It's rock, right? This is alarming to me.
Can't take magnesium supplements.
Yeah, exactly. The limestone's taking magnesium supplements, which is how it becomes dolomite. Yeah, this is a little bit alarming to me, but the fact is that sedimentary rocks are full of space. Even when the sediment...
So it is from space.
From inner space. Not outer space. Even when sediment particles are packed together, there are still pores between them where water can seep through. So when there's magnesium dissolved in water, it will replace some of the calcium, and that gives us dolomite.
Okay, got it. So like the rock is like porous, and then magnesium's being carried in the water.
Yeah.
And the pore, to the extent that the water can get in, it moves the magnesium into the rock.
Yeah. And like any place where the bedrock is primarily limestone, you tend to have lots of caves because limestone is more porous than many other rocks, and so it tends to be eaten away by water. So places like the...
Is that how like the Mammoth Caves and stuff work in Kentucky?
And in a lot of the Appalachians you have. Exactly. Karst caves, which are made of limestone mostly. All right, so I'm supposed to do this now. Following my own directions very badly. It turns out that there are ancient Silurian reefs all over the Midwest, dotted across the landscape. I've highlighted 2 in the Chicago area in red here. Sometimes they stick out of the surrounding bedrock as little islands. So the map that we're looking at is a hillshade map that shows the topography of the land. It's from the U.S. National Map, which is like, a website you can go to, check it out. It's got tons of awesome layers to look at.
Ooh.
The National Map. So because the reefs stick out from the landscape, it makes them easy to access. Basically the easiest place to access stone in the region, because most of the stone is under soil. So there are stone quarries at basically all of the dolomite reefs in the Chicago and Milwaukee areas. The biggest quarry by far is in Thornton, Illinois on I-80. Actually, it's literally bisected by I-80. If I zoom in here, you can see the road cutting through between a pit on the north side and 2 pits on the south side.
It is a giant deep pit, and you drive your car on a tiny little road over the pit.
Yeah.
And so when I was a kid, my parents would take me to the mall in Oak Brook sometimes, or, sometimes we'd be going up to Chicago or back from Chicago, and traffic everywhere else was just horrid. And we ended up on I-80.
Yeah.
And my parents would be like, did you know that the mafia throws those bodies in the pit here? And this pit is filled with the bodies of people who crossed the mafia. And my brother and I would be like, oh, We'd be shocked.
Is that
We'd be
verified?
afraid of the pits. I'm sure that the mafia has thrown at least one body in the pit,
Yeah.
but yeah, it's the mafia body pit.
Yeah. So even though this was one of the most prominent outcroppings of stone in the Chicago area, it is now one of the most depressed in terms of elevation.
You started up when there was high rock. You got through that. Well, it's like there's still rock here. Let's keep going.
Just keep going. How far does it go? Yeah.
Yeah, it is. How far does it go? Do you know
How
the current
deep?
depth of the pit?
It should tell me. Hang on. There should be a tool in Google Earth that does transect. Is it part of the ruler?
Ooh, that's
tool?
gonna get this map defunded by the government because that says trans in it.
Yes, that's true.
I'm gonna Google search how deep is the Thornton pit,
That sounds like a better way.
and then AI is gonna give me an absolutely terrible answer.
Oh, elevation profile. Here we go. Okay. Google Earth says it's about 270 feet above sea level, which is approximately 340 feet deep.
It says like 450 feet deep at its deepest point, but I
Yeah.
don't know what that. But maybe 350 on average.
But I
would
think it's
be.
also measuring from the rim here, which is a little higher than the surrounding land.
Right.
Maybe.
But yeah, okay, we're getting a ballpark. We're getting a ballpark here.
Yeah, we're doing a ballpark estimate. Oh, and the other cool thing about the Thornton Reef, the Thornton Quarry, is that the North Pit has been converted into an emergency overflow reservoir for the Chicago deep sewer system for managing flooding, which is cool. Just
That is cool.
repurposing this big stone pit to hold water.
We love tunnels.
We love tunnels. This is a tunnel positive podcast. Compared to limestone, the dolomite is not considered to be as strong or attractive as a building material, so mostly it gets ground up as gravel and used as an aggregate.
So is it just like brittle?
I think it is. Yeah, I think that's what I'm not 100% sure, but I think it's just more brittle as a building material than the limestone. Yeah. So mostly goes into things like road beds and concrete. Then the other dolomite reef in the Chicago area is Stony Island. So I assume you've heard the name Stony Island, living on the south side.
Yes, I have.
Famously, Stony Island Avenue, which goes about
It's
as
where you
far
get off
south.
the expressway when you're going to Hyde Park.
Yeah, exactly. I think Stony Island Avenue goes about as far south as Stony Island itself. So I think it's just named after the fact that it goes to Stony Island. There it is, Stony Island Avenue. Going right past the edge of Stony Island.
Ooh.
But yeah, it's also got a funky shape, right?
It's like a peanut.
It's a peanut. Often described as dumbbell shaped, yeah. So usually these ancient dolomite reefs are shaped like a dome. So the thinking goes that maybe Stony Island was formed from two adjacent reefs that fused together.
I could see it.
And later on, during glacial geology, both of the reefs had an impact on the directions that the glaciers went. Basically, they had a little bit of an effect where they would redirect glaciers because they were harder raised
So
rock.
it'd be like just like a little bit of a bit of a tap.
A little bit of a nudge. Exactly. And I think that Stony Island Reef survives much more intact today. There were some very small quarries early on in their history, but they became occupied by the neighborhood of Stony Island. Nowadays, I think it's called Calumet Heights, but also in the past known as Pill Hill, specifically the part that's on top of Stony Island because of the hospital there.
Which one is that? Is it Jackson or?
I think today it's called Advocate Trinity Hospital. It's Trinity Hospital.
Okay. Or wait, no, Jackson's like right on Stony. Jackson's like right on the street. If that's what I'm thinking of.
Sure, yeah. In the past, yeah, it was originally called the South Chicago Community Hospital. Okay, so at this point, our narrative is going to skip 300 million years because during all of that time, there were either no new rocks being deposited around Chicago, or, even worse, the existing rocks were actively being eroded away. So we see basically no geological record until about 15,000 years ago. And for geological context, 300 million years is about half of the time that multicellular life has existed on Earth. So that's a huge chunk of time that we just don't have any rocks being deposited in this part of the world. Around 25,000 years ago, the glacier sheets of the Wisconsin episode reached their maximum extent. I think I should probably spend a little bit of time explaining glaciers and how they work because maybe it's just me, but I find them totally counterintuitive. First of all, I should clarify there are two main kinds of glaciers. There are the glaciers that are restricted to mountain valleys, and then there are the expansive glacial ice sheets. Something that always confused me about glaciers is how they're so often invoked to explain our present-day landscapes. In the Midwest, people will tell you that the glaciers flattened out the landscape like a bulldozer. But then you go to Yosemite Valley in California, like a deep U-shaped valley, and then the people will tell you that that was formed by glaciers.
Or it was like carved up by the glaciers.
Yeah, exactly.
That's usually the term they use is, oh yeah, this is like, they've got the mountains because it was carved up by the glaciers.
Yeah, the shapes of the mountain were carved by the glaciers. Yeah, and the answer to this paradox is it depends on the interactions between the glacier and the bedrock beneath it. So if you put a bunch of snow and ice on top of a mountain range, it'll tend to get caught in between the mountain ridges, and as it slides down, it'll carve deeper channels as it goes. But once you get enough ice in one place, the shear mass starts to overwhelm the local topography. We see this today in the ice sheets on top of Antarctica and Greenland. A really massive ice sheet will be miles thick in the center, but it'll get progressively thinner around the edges, and that's what causes the ice sheet to spread out. It's literally the need to redistribute the weight, and gravity just pulls it down.
Okay, so that makes sense where it's like it's kind of like level, but also there's so much in the middle that like, oh, I guess it wouldn't be level. It would be more unless there was the land under it already was very, very uneven.
Right.
Or so it must be like kind of like a low grade, and you don't even notice the low grade like.
It's actually crazier
flatter?
than that. Yeah. So like even if the land underneath it was flat, the crust itself, the continental crust, actually dips underneath the glacier from the weight of the ice. So not
Okay,
only
so
is it...
it's like if you're like sleeping in a really, really cheap IKEA bed,
Uh-huh.
and then
Yeah,
like
it's like a waterbed.
yeah. But then the things under the bed slats like break because they don't like people who are over like 120 pounds, and you're
Yeah.
like, how do they keep selling this?
Yeah, exactly. But yeah, it's just the sheer weight of the ice forcing it to redistribute toward the edges where it's thinner.
What's not the subject, but what is the driftless area in Wisconsin?
Oh, that's its own whole topic. So there's this one sort of spot where none of the main glacial episodes ever reached. So it's never been drifted by glaciers. It's never experienced Need for Speed Wisconsin drift. Need for Speed. Is that the video game?
Need for not
Fast
much
and
speed,
Furious.
'cause glaciers don't go very fast.
Yeah, exactly. Slow and furious glacial drift.
Slow, sedimentary.
So when we're talking about ice age glaciers, we're talking about the continent-sized ice sheets that plowed over everything in their path. But there was still some room for ice sheets to be channelized by local topography, especially around the edges where the ice is thinner. For example, during the Wisconsin, which, by the way, I should have mentioned, the Wisconsin glaciation was the last of the major glaciation episodes during the ice ages.
Like worldwide or in the region?
Yeah, worldwide.
Oh, cool.
But it's named after Wisconsin. I think that they might call it different things like in Europe.
Oh, we're like different areas that were impacted by that last phase of it. Whatever's the nearest one to you, you call it that. Like
I think they might use local terms there, yeah, local names.
Like the Lithuanian period or whatever.
Potentially, but I can't speak to it.
Yeah, right, yeah.
Editing Xavier here. Turns out that in Europe, the equivalent glaciation episode to the Wisconsin glaciation is called the Weichsel
glaciation, named after the German name for the Vistula River.
So during the Wisconsin glaciation, the hard dolomite bedrock of the Niagara Escarpment separated the ice sheet into two lobes. To the west, you have the Green Bay lobe, and the east, the Michigan lobe. And those, help carve out those bodies of water, respectively. Beyond the future Great Lakes, the colossal ice sheets behaved much more like we'd expect. They scraped soil off in places with high bedrock elevation and dumped them into the basins and valleys with lower bedrock. I mentioned earlier that the area around Chicago has higher, and therefore older, bedrock than either the Michigan Basin to the northeast or the Illinois Basin to the southwest. So what we're looking at here is the Illinois Basin to the southwest mostly. As we'd expect, the soil is deeper in both of those basins. The squiggly-shaped areas in the Illinois Basin, where the soil is up to 500 feet deep, so that's in like orange, pink, those would have been river valleys that the glaciers filled in with sediments. So it's kind of like pushing sand into the cracks between the patio bricks. I assume you did that as a kid just to mess with ants.
I don't think I ever did. But we had a wooden patio.
Oh, sure. Okay, so it would be off the ground. The other really striking pattern we see is that the parts of Illinois that are furthest from Chicago never got covered by glaciers during the Wisconsin episode. Going back to this map. In orange is the Wisconsin glaciation. In red is the Illinois glaciation, which happened, 10,000 years before that. Oh, I actually wrote that down. This is good. The Illinois glaciation happened 130,000 years ago, so there was a big gap of about 100,000 years between those ice ages.
I'm sorry, I think the Goodyear blimp is outside my window.
Oh, that's more important.
I'm sorry, 1 second.
Yeah.
Yeah, that's it. That's the Goodyear blimp.
Bitchin'.
I was taking a picture.
Yeah, go for it.
Love a blimp.
You gotta love a blimp. I've got some good Goodyear trivia.
Ooh,
which is, as we know, the headquarters of Goodyear are in Akron, Ohio, which means, also because of rubber, they were making blimps, but they also dallied in other types of airships. So, for example, the U.S. Navy Zeppelin, USS Akron, was named in honor of the America's airship producing region. Yes.
So, why is it tire companies that keep getting so out of their lane? Like Goodyear's got its blimp. Michelin has the restaurant guide.
That's
I know how that one happens.
I guess that's connected
but
to...
Actually, it might be specifically in its lane where you drive to restaurants.
That's right. The lane of driving. Yes. Yeah, because for Michelin, it was about promoting driving.
Yeah, you could drive to different places. Here's some places we enjoy eating.
In the early 20th century, right, when it was new. And then for Goodyear, it's because they were making rubber for blimps. And then they kind of, from there, they also had dallied, like I said, in Zeppelins.
Yeah, it's like, well, I guess we have these blimps.
Yeah.
Every once in a while, I look at prices for used blimps on the internet, and there's not that many used blimps.
No. There aren't that many blimps, period.
Used carnival rides, used houseboats, used blimps. I'm really scouting out my options.
I think World War II was the golden age of blimps, actually, because we built we built a fuck ton of them and just had them patrolling like the entire Pacific and Atlantic coasts, like all the way down down through Chile and Argentina.
It's crazy.
Yeah, because they have great endurance, right? You just keep them up forever.
Right, yeah. And then they blow up.
No, they're not filled with hydrogen. No. Okay, now we're really deep in the weeds. This is Xavier's Airship Corner. Because I will not tolerate Hindenburg and Graf Zeppelin slander. Those Zeppelins were built specifically to take helium. So they had larger envelopes compared to their weight than older Zeppelins, which had been designed to be filled with hydrogen. Helium does not burn. It's a noble gas. But it is more massive than hydrogen, so you need more volume of it to become buoyant.
Okay.
But they were designed for that, but because of the restrictions on Germany after the First World War, they were not allowed to purchase any American helium.
Oh, no.
So they were filled with hydrogen anyway.
So you shouldn't have this. This is the thing. This is designed for it
Yeah.
specifically not to do.
It was not a design
Nine.
It was not a design
Nine.
issue. It was more of like an economics and like political
Right, like they
relations
shouldn't
issue.
have put those up filled with that.
No,
like
they shouldn't
we
have done it.
specifically told you on how to operate this. Don't do that, and
Yeah.
they went and they did it.
But like so much
That's crazy.
during Nazi Germany, they just sort of took things that were already in motion and like branded them as their own. That was so far off topic, but it's wonderful. Okay, so the Illinois episode was around 130,000 years ago compared to the Wisconsin glaciation, which only started around 25,000 years ago, so much older. But that means that western and southern Illinois show the results of over 100,000 years of erosion. And consequently, the soil is under 25 feet thick in most of that part of the state, which is where I'm from, by the way. The slightly wavy part of Illinois. Despite its higher bedrock elevation, there is still a substantial amount of soil in the Chicago area, somewhere between 25 to 100 feet. Because unlike the Illinois basin soils, which were dumped bulldozer style by advancing glaciers, the Chicago soils were deposited in a period of time when the glaciers were actually shrinking. So how does that work? For the answer, we're heading to Greenland, where we have active
Ooh,
glacial ice sheets.
that's not the Chicagoland area.
No, I know, but it's informative. So what we're looking at in this picture is what we call a end moraine, or a terminal moraine. That's the dark band on the edge of the glacier. Like we saw earlier, glacial ice sheets are thicker in the center and thinner at the edges, which means the largest amount of precipitation and snow accumulation happens toward the center of the ice sheet, while simultaneously, the ice at the edge is always melting. So if the amount of snow accumulating at the center is the same as the amount at the melting away at the edges, we say the glacier is in equilibrium, and it will appear to stay in one place and not move. But remember, glaciers are always moving. So really the glacier is more like a conveyor belt.
Interesting.
And it'll pick up and carry anything and everything on that conveyor belt. They carry all sorts of junk. Boulders, gravel, sand, silt, clay, and any other debris they come across.
So the center is what creates more ice, and it moves, or is it more dynamic of just moving around, as opposed to like out from any particular
It's
place?
out from the center, exactly, for like a big ice sheet. Because like even if the same amount of precipitation happens on the edge of the glacier as in the center, it's going to melt off the edges quickly
Right.
and accumulate toward the center. So yeah, a glacier is also a three-dimensional structure. So it's got rivers of water that run over the top of it, and it's got water that runs through caves and tunnels inside of it. And then finally, it's got water running through channels underneath it at ground level.
A tunnel in a glacier or a cave in a glacier must be crazy.
Glacial ice caves, yeah. They are one of the types of cave.
And we're a cave and tunnel positive space on this
Yes,
podcast.
we're all about tunnels. The water helps lubricate the flow of the glacier, and it also moves the sediment around inside of it, even carrying it up to the edge of the glacier where it's deposited. So the landscape just beyond the thin edge of the glacier can start to look a little bit like a river delta, where fans of sand and silt are being spread out.
We're fans of sand and silt too.
Yes. And then if you think about the boulders and gravel that are being carried around by the ice itself, those are carried up to the edge of the conveyor belt, right? And then they're dropped off as the ice melts. I guess I should also say that the glacier that's in this picture is the same one that we see to the right of the picture here. And if I zoom in, you can see those dark bands, which are
cool.
moraines that are forming in the present day.
Very neat.
Very neat. So back to Chicago land. So depending on the climatic conditions, our glacial ice sheet will either be growing, shrinking, or appearing to stay put, like I said, equilibrium. When it's growing, it pushes sediments along with it and creates the thick soil that we mentioned earlier. If it's shrinking, it drops sediments all over the ground that it previously occupied and leaves a scattered jumble over a wide area. And then finally, if the glacier's in equilibrium, it'll deliver the sediments to the furthest edges and drop them off there. And that eventually builds up into a ridge, which we call an end moraine. So this picture shows the systems of moraines throughout the Midwest. It's not really like super geographically accurate, but it does schematically show all of the major moraine bands, which are arranged in a particular way. You see the pattern?
Yes, they do.
So they're sort of in concentric rings around the Great Lakes because they were deposited parallel to the edges of the glacier. So in that way, they're kind of like the rings on a bathtub. Bathtub rings show where sitting water was left alone for an extended duration, and moraines show where the ice sheets were at equilibrium for an extended duration. The closer we get to Lake Michigan, the younger the moraines are, because the glaciers were shrinking during this time. And also, the reason we don't see older moraines underneath is because whenever the ice sheet would expand, it would wipe out any moraines that it previously deposited.
And that would just kind of get pushed into like the next moraine.
Yeah, exactly. Or even just pushed into the soil underneath the glacier. So each line of moraines was a miniature glacial advance that reached its furthest point, sat at equilibrium for a while, and then eventually melted away. Even though the continental ice sheet was losing ground over the span of thousands of years, it was still periodically advancing and retreating on the scale of hundreds of years. So each moraine band is a record of a small temporary advance during this long period of decline.
So there was like the temporary advance, and then it would like retreat like relatively quickly.
Yeah, I think so.
Like relatively quickly, of course, by like geological scale.
Well, I want to be clear that glaciers move extremely fast on a geological scale.
Okay, yeah, they're not rocks.
Because when we were talking about like the Dolomite and limestone formation, that was like, hundreds of millions of years ago.
Right. And this is like
just
years.
Like 10,000 years, yeah. Which goes into my next point, which is that during this stretch of time, there were people living in North America. We have to imagine that at least some of them must have climbed up onto the glacial ice lobes to have a look around. I mean, I would have.
Oh yeah. What else is there to do?
Yeah, exactly. You gotta check out what's around. It must have been pretty cool.
Yeah, no, it must have been sick.
So for our story, we're more interested in the dark green and light green bands of moraines along Lake Michigan here, as well as the dark blue one right up next to the lake. The dark green ones are called the Valparaiso moraines, named after Valparaiso in northwest Indiana. And the light green one is the Tinley moraine, named after Tinley Park, Illinois. And finally, the dark blue ones are called the Lake Border moraines.
Named after Lake Border.
Lake Border, the lake, yes.
The lake.
Geologists used to think that the Lake Border moraines were laid down after the Tinley moraines, but it turns out they were laid more or less at the same time. So here's a more accurate map, again the hillshade map from the national map, showing the topography of the Calumet area. I'm going to add some lines here that show the extent of the Valparaiso moraines. You can kind of see a plain to the south, especially on the southeast here. That's the former swampland of the Kankakee River. Otherwise, it's not a super clear-cut line where the moraines begin and end, and the moraines themselves are pretty lumpy. The geology term for lumpy terrain is hummocky, Hummocky. So it's a landscape that's a mix of bowls and hills. Many of the bowls have swamps or bogs or lakes in them. Oftentimes, as the glaciers retreated, they would drop off blocks of ice among the sediments, and so when the blocks of ice melted, the soil around them would sag and leave a bowl-shaped space that water would fill in. Because the lake beds that form this way are so shallow, they're called kettle lakes. The best ones in the area are near Valparaiso. Let's see if we can find them. Here we go. Yep, and you can see that this is within the confines of the Valparaiso moraine, and we see not only raised hills, but also bowls that are filled with water. Now I'm going to add lines to show the Tinley and Lake Border moraines. The Tinley moraine is pressed right up against the northern edge of the Valpo moraines. And the Lake Border moraines are sort of separated. So you can see this little chunk here north of Chesterton, and this little chunk near Hobart, and this chunk over here, which is called Blue Island. Oh, I was going to say, this little chunk here near Hobart is called Hobart Island, but the most raised part of its ridge is actually, technically, in Merrillville, which is just south of Gary.
My aunt lives in Hobart.
Nice. But not on the island.
No, not on the islands.
I mean, it's not an island today, obviously.
No. It's Merrillville just has US 30 running through it.
Yeah.
There's a mall in Merrillville.
Yeah. Okay, so on the topic of Blue Island, that is the larger and more famous of the two islands left behind by the lake border moraines because it was a premium real estate development in the late 19th century. The name supposedly comes from blue prairie flowers that bloomed on the ridge, and the fact that the ridge was clearly higher than the surrounding terrain. So today, it's the neighborhoods of Beverly and Morgan Park in Chicago, and there's also a suburb called Blue Island at the south tip of the ridge. Blue Island is the highest point of elevation in the city of Chicago, which is not saying much.
No, really, it really isn't.
But that elevation gave its residents protection from both sewage and mosquito-borne diseases. The Rock Island Railroad started running commuter trains to Beverly, Morgan Park, and Blue Island as far back as 1870.
So there's the Rock Island Railroad there.
Mhm.
Is that why there's the bar in Blue Island called Rock Island Public House?
Yeah.
I always wondered because it's like Rock Island is another place.
Yeah, it's all the way on the other side of the state.
Yeah, it's on the exact opposite side of the state.
But in a roundabout
and
way.
So I always was wondering, like, was there some relationship between the owners and like that city or
No,
it was the railroad.
Yeah.
Railroad.
Because the Rock Island Railroad was named after Rock Island, Illinois in the Quad Cities, because it was the first railroad bridge built across the Mississippi River there.
Right, because there was and there still is like a U.S. Army depot there too. So
yes, Rock Island Arsenal.
I understand that they want to hook other things up to that real quick.
Yeah, there's a lot. As so often happens while recording an episode of Chicagoland, I just start recording a different episode of Chicagoland in the middle of my episode. Yeah. Okay, so the Valparaiso, Tinley, and Lake Border moraines were all deposited during a pretty quick period of glacial melting, around 1,000 years ago. That leaves us with still approximately 14,000 years until the present day. Which is good because in order to have a Chicago, we first need to get rid of the permanent sheet of ice filling up all of Lake Michigan. So while it would be tempting for us to just say that the melting glacier provided the water for Lake Michigan, there was actually a lot more going on during those 14,000 years. Remember that the continent-wide ice sheet was miles thick at its core, so there was way more water held inside of it than could ever fit into all the Great Lakes. So where did all the extra water go? Well, the only place it could go, which was downhill, to the oceans. By this point, the Valparaiso moraines were totally surrounded the southern end of Lake Michigan, like the lip of a bowl. Of course, if we keep filling up the bowl, eventually the water's going to start spilling out somewhere. So the glacial meltwater was trying to find a weak point in the moraine that it could puncture, which turned out to be to the west of Blue Island. Today there's a wedge-shaped highland, and that's part of the Valparaiso moraine.
Okay.
But when the moraine was originally formed, it wasn't wedge-shaped, it was just part of the moraine. So we call this Mount Forest Island, that sort of wedge shape.
I love how creative Chicago suburb naming is and things in the Chicago suburb naming is. It's like Lake Forest.
Yeah, I want to make an index of all the neighborhoods and suburbs that are named after lake, forest, park, mount, hills, heights.
Yeah, a while ago, some guy made a Chicago not neighborhood, but a Chicago suburb name generator.
Yes.
That basically just scrambled stuff, and it would be it would take parts of names. So
Yeah.
it would be Palos Forest, which I think is an actual thing.
Maybe.
Or Lake Ridge, Ridge Park.
Yes. Oh, yeah. Yeah. And I've joked previously on this podcast that every place in Chicago is named a park. When the floodwaters passed over the top of the moraine, it quickly eroded away two broad channels for the water to escape through. So those labeled here as the Des Plaines outlet and the Saganashkee outlet, or usually Sag is short for Saganashkee.
Mm.
Then the two channels flowed together into the Chicago outlet. And then from there, the water was free to flow south into the Mississippi River and ultimately the Gulf of Mexico. So the bottoms of these channels are really broad and flat compared to any other river bottoms in the area. But the slopes on the edges are relatively steep, probably some of the steepest natural topography anywhere in the Chicago region. Today, only a small portion of those broad river bottoms are occupied because the volume of water that needs to go through there today is much smaller than when all of this meltwater was pushing through.
Right.
Meanwhile, the new lakeshore to the east was starting to accumulate sand. Kind of like the moraines during the preceding 2,000 years, newer shorelines would be added sequentially as the water level dropped. This is a graph that shows the water level as it oscillated over time. The prehistoric shorelines that left behind sandy beaches are called the Glenwood, Calumet, and Tolleston shorelines. Just like with the moraines, any beaches that might have formed when the lake was lower than the current level would have been washed away again when the water level rose. So there's not much geological evidence from the periods of time when the lake was lower than it is today. So that would be like this period here where there are question marks, and then this big extended period where it was much lower. I should also mention the timeline of events that I'm covering here. I got from the book Calumet Beginnings by Kenneth Schoon, who made the original research by Krystowski and Thompson much more accessible. So credit where it's due. Okay, so in cyan here, light blue, we have the Glenwood shoreline. That's the first ancient shoreline, and it was formed during a 2,000-year phase until around 12,000 years ago. Where does all the sand come from?
Where does all the sand come from?
Generally, sand gets collected at the mouths of rivers because the slower waters in seasoned lakes cannot keep the sand grains suspended in the water because they're a little bigger than like mud, silt and stuff.
Yeah.
Whereas glaciers carry objects of all sizes indiscriminately, rivers actually sort out the different types of sediments, different sizes. From there, the sand gets moved around by the waves and wind. In Lake Michigan, the prevailing winds come from the west and blow the sand east toward Indiana and Michigan. So there's also a lot of dunes in Michigan. Waves help to push the sand toward land and they collect it into dunes. The dune forming process started pretty much immediately in northwestern Indiana as soon as glacial meltwater formed early Lake Michigan. Because the Chicago outlet, the meltwater outlet, drained the lake whenever it rose up to the height of the existing moraines, they formed the original shoreline. So that's why the Calumet shorelines pressed up against the Tinley and Lake Border moraines. But you might notice the sand dunes were also adding new shoreline using the moraines as a nucleus. You can see that there are banks of sand that stick out into the lake, which are called sand spits. During the Glenwood phase, there were two major spits. The one on the west, here, just south of the Thornton Reef, goes through Glenwood, Indiana, which gives the name to the Glenwood shoreline. You can actually drive on top of the spit today. It's called the Glenwood Dyer Road. The other spit used bits of the Lake Border moraines as its nuclei, so like Hobart Island and this bit over here to the east. To the west of Hobart Island, the sand actually created multiple spits at the mouth of a large, calm lagoon. So I've kind of approximated where those spits were, sort of fanning out. The lagoon is in the valley between the Lake Border moraine and the inner Tinley and Valparaiso moraines. So on the topic of sand spits happen in places where tides and wind push the sand dunes past the original shoreline and out into the water. So the spits...
Oh, that looks so cool.
Yeah, exactly. This is a really cool sequence of images. The spits start to propagate, and they start to self-propagate, and they can get really long because once there is some sand sticking out into the water, it can always be pushed further into the water.
It's like a claw expanding out.
Yeah, it's really cool, isn't it? This example is off the coast of Erie, Pennsylvania, and it's currently forming in the present day. It's really similar to the spit that we saw in geological history in Indiana.
Mm.
And this is a series of aerial photographs that show the shoreline eroding as the sand gets pushed out further along the spit. You can see also how like the shoreline pushes, the front of the sand gets pushed backwards.
Yeah, where it gets pushed. Does eventually like this like become an island, or like does the spit just
I suppose it could. But if the processes that we're looking at in Indiana are any indication, what'll probably happen is that they'll fill in a calm lagoon behind them, which will push the lake shoreline further north. So that the sand spit, the outer edge of the sand spit will become the basis for the next shoreline after this. And you can see what it looks like today, which is it's even pushed further out.
Mm.
The next shoreline is called the Calumet shoreline. So the old lagoon got filled in, and the new sand dunes started forming along the north edge of the former sand spits. So the process I just described. The Calumet shoreline only had one major sand spit that protected the lagoon, which is a familiar pattern to have that. Now that the water level is a little lower, the Thornton Reef was at the surface, and it stood on the west side of the lagoon's mouth. So you can see it here, and you can see how it influenced the shoreline formation. Sort of like a little nucleus for dune formation.
Yeah.
Nowadays, that spit here across the lagoon is called Ridge Road.
Oh, I've often driven on Ridge Road.
Yes,
because that kind of goes through like it goes through Munster, it goes through Griffith, it goes through like just a bunch of towns down there.
it's a major thoroughfare.
Yeah, it is, and like except for like certain parts of it, I really like, you really don't think of it as that elevated, and then all of a sudden it hits you that it kind of is.
Yeah. Like a lot of the ridges that we're talking about are very subtle, especially when there's properties, when there's buildings built on the properties, it can be hard to see.
Right, and there's so much development, and like some of it's been like, there's been like grading of certain plots of land along like the front of it.
Yeah. But there are still traces.
Yeah. Oh yeah, absolutely.
So Ridge Road stretches from Thornton, Illinois to the Glen Park neighborhood of Gary. Then over by the Chicago Outlet, if we head over there, Blue Island and Mount Forest are now combined into a single island. So I should say we're looking at the green lines here. There are also a couple of small islands nearby. To the west is Worth Island, this little one here. I guess it's to the west of Blue Island, it's to the south of this mega island. And to the east is a small sandy island at the tip of a narrow spit. Today, we call that island Stewart Ridge. And there's a commuter train station named after it. So we're learning a lot of where some place names come from.
Again, incredibly creative.
Yeah.
By the municipal gods that be in the Chicago suburbs.
Mm-hmm. All the islands and ridges.
Because, like, I've always actually wondered where a lot of, like, the island names came from.
Yeah.
Or it's like, clearly this is not an island.
But in the not too distant geological past, it literally was an island.
It was. Yeah.
Both Blue Island and Stony Island. So compared to the Glenwood shorelines, the beaches of Calumet shoreline were formed pretty fast, around just 600 years. So that's what we're looking at here in this little bar at the bottom called Calumet. After that, we get to some really weird events. First, during the Algonquin phase, there's a drop in the water level, followed by a slight rise. Apparently, even while the lake was draining, the continental crust was rebounding from all the mass no longer being on top of it. So basically, the ice sheet had been weighing down the continent, and once that weight was removed, North America as a whole got lighter, making it more buoyant on top of the liquid mantle.
Just like sprung up, like boing.
Yeah, I think it's still in the process of rebounding to a limited degree, even today. So, even though there was less water in the lake, the basin got smaller and the water level rose a bit. So instead of depositing sand, the waves cut into the shoreline and left behind some bluffs. So that's in magenta here. So we can see them just north of the Calumet shoreline. And then we go back to the graph. After the Algonquin phase, A second drainage channel for the Great Lakes opened up to the east. During the Chippewa phase, the glacial meltwater was redirected into the Ottawa River in Canada and from there to the Gulf of St. Lawrence. So as a result, Lake Michigan dropped to its lowest level ever, which we can see this really dramatic drop here.
Yeah, that is like, I feel like that would be like, people would notice it in their lifetimes being like
Probably.
vastly different. If you're looking at that, like, you know, someone who lives like 60 years would probably be like, the shore used to be here.
Yeah, yeah.
Now it's over there.
You can see like, yeah. That's really, I mean, it must have been really bizarre to like watch over decades as the land moved inward. Like Lake, what's that lake that got drained out near the Caspian Sea? Or the Aral Sea?
Oh, the Aral Sea, yeah.
I'm not sure it would have been that dramatic, but still.
Because that was crazy.
Yeah. A whole lot of the lake bed became terrestrial habitat. Divers have even found 8,000-year-old tree stumps preserved underwater 10 miles north of Gary. Even though so much water drained out of the Great Lakes during the Chippewa phase, the continent was still slowly rebounding, which is why we can see the water level slowly rising in the graph. It took 5,000 years, but eventually, the lake rose back to almost the level where it had been before, and we call this one the High Tolleson shoreline. The Low Tolleson shoreline comes later. That's just the modern-day shoreline, actually.
What's the Mid Tolleson shoreline?
Yeah, so it's kind of a sequence, especially to sort of the western part, sort of this portion here around Indiana Harbor. There was sort of a sequence of sandy ridges formed as part of the Low Tolleson shoreline. So maybe you could call that the Mid Tolleson shoreline. The High Tolleson shoreline lasted for about 1,000 years until 3.8 thousand years ago. So that's what, like 2000 BC?
Mm-hmm.
You can see more dry land than ever. Both Worth Island and Mount Forest / Blue Island area are larger than before. The Dolomite Reef at Stony Island has finally become a true island.
Ooh.
And the lake water is draining through the Chicago outlet again, now that it's high enough to reach it. And once again, there is a long sand spit in front of the older Calumet shoreline, and that creates a new lagoon. This one's really long. That's actually going to end up becoming a lot of the lake bed, a lot of the riverbed for the Calumet River. So we call it the Calumet Lagoon. So this sand spit here that forms this shoreline, it cuts through the Tolleston neighborhood in Gary, which of course gives it the name of the High Tolleston shoreline. And then Michigan City Road is a street in Hammond, Indiana that runs along the ridge left behind by the sand spit, but in Gary, the rectilinear street grid doesn't incorporate the ridge, although it didn't obliterate it. There are several rivers that flow into the lagoon, including the Calumet River, the Salt Creek, the Deep River, and Thorn Creek.
Oh, there's a water park named the Deep River Water Park.
Deep River Water Park.
In Northwest Indiana.
Nice.
It's simply splashtastic.
Splashtastic.
It's not paid programming.
No, you're advertising for free.
It's been so long since I've been there. I've got no idea how good it is.
So you can see there's like these eroded river valleys here. I think this one through Hobart is the Deep River. And then this one in the middle is Salt Creek. Yeah, well, there we go. Salt Creek Commons. There we go. And then the one to the east here that cuts across obliquely through the moraines is the Little Calumet River. So you can see those eroded valleys. And then once this long lagoon here dried out, it became the riverbed for the Little Calumet River. And we're getting tantalizingly close to actually forming the Calumet River watershed. But unfortunately, we've run out of time for the episode.
Darn.
Once we see how the river formed, we'll be able to understand how it was undone so quickly. So that's what we'll get into next episode, the geological creation of two separate rivers, the Grand Calumet and Little Calumet, and then how human activity reconfigured the natural waterways, at first haphazardly, and then later on an industrial scale.
I'm excited.
Yeah. Things can only get worse from here. Allie, where can the good listeners find more from you?
So I'm kind of offline right now. I have an account on the website formerly known as Twitter at Panail Decalcify. I have a Blue Sky account that I hardly post on, which is just Ali Mezzi, ALLIEMEZEI. Yeah, so if I do get more online again, I will start posting in those places.
Heckin' yeah.
On occasion, if I guest on other podcasts, I probably will drop a link there on them.
Yeah.
Yeah.
Lovely.
And you can probably find me at several locations around Chicago.
Yeah. Track her down, folks. This is an
Find
official.
where I live. Please don't.
Triangulate from the Goodyear blimp and the whatever
Yeah,
else.
from the Goodyear blimp and like the lighting source.
Oh yeah.
Of like what time of day it would be, where the Goodyear blimp was. You can do it. You can do it. I believe in you.
Beautiful.
I believe in you, and I'm terrified.
And with that uplifting message, it's been a lovely time. I'll see y'all later.
See you around.
You've been listening to Chicagoland, a production by Articulata Publishing. Chicagoland is written, edited, and produced by Xavier. The Chicagoland theme was composed by Chris Robbin. That's CHRISROBBIN.